Thanks. So actually the emoji are part of the paper title. So if you cite that, you have to include that. All right, so let's talk about emoji. And I think a first question many people might have is, why do something with emoji at all? What are they useful for? And I brought two examples of that. So on the left, we see Roger Federer, who quite enjoys using emoji. And in that tweet, we can really see the playfulness in communication that you can achieve by going in that direction. And as we know, Twitter limits how many characters you can use. And by making the characters you use an emoji, it buys you a bit more expressiveness. And in the top, I put an artificial example that kind of shows you how just one emoji can drastically change the meaning of a message. So if you reply to the question, what's up, that not much, but Susan's coming over later, and then you do the smiley face with hearts in the eyes emoji, that obviously sends a very different kind of message than if you use the kind of shocked, frowning, annoyed face emoji. Two very different kinds, right? So there is definitely some use there in emotional communication, some playfulness. And what I want to start with really is to get you to try something. Let's see whether this works. So please take out your phone, and I want you to try to enter this message. So it's like the T-Rex emoji, and then the comet is coming down, and then fireworks. So they might look different on your phone. And I'm not going to give you a ton of time. So try to quickly enter that. And I'm going to cut you off in a bit. All right, time's over. I'm assuming most of you probably didn't get all the way to the end. Which is kind of weird. It's 3 characters, right? If I had asked you to enter, hey, 3 characters as well, you probably would have all been done at this point. So something's different there when we do emoji or when we do normal text. So let's see. One big difference is that there are a ton of emoji. So at this point, we're looking at almost 2,000, just the bare base emoji. And then you can do skin tone modifiers. You can assemble families. There's flags. All those, I think in Windows today, 50,000 emoji are supported. So it's just a very large amount of time. So imagine trying to find one specific one just in the 2,000 emoji that there are. So if we look at this in comparison to the text entry that we're used to, so a QWERTY keyboard, maybe a gesturing keyboard, but some kind of Latin text entry, we see a range of differences emerge. And one you already saw, it's just a huge amount of emoji out there. And you're probably unfamiliar with most of them. And I asked you to do the T-Rex, and quite likely you don't even have the T-Rex on your phone. It was just approved earlier in this year, and it's kind of coming out now, but if you don't have a super new, updated phone, you probably don't even have it. And how would you have known? You were probably unfamiliar. I'm definitely, I don't know all 2,000 emoji by heart. Whereas with Latin text, yeah, we kind of know those letters. There's not that many of them. There's some variations, and I put some here, but overall, it's a fairly small set. Also, if we use emoji, then it's not really clear what they're used for, right? There's some ambiguity there. So I put a fire here, and that certainly can mean very different things. If I put a fire in a tweet, maybe something's actually on fire, but that would be bad. But maybe I just met somebody that's kind of attractive, and I'm on fire or something. So there's some ambiguity here. We don't really have that with Latin text. If I use an A, it's pretty much an A, and only once we assemble a few characters together, some more defined meaning emerges. Which also hints at the fact that if we use Latin characters, they're really general purpose. I can assemble them in some way, and I get a love poem, and I can assemble them in another way, and I get a Kai paper out of them. Whereas if I use emoji, it's more of a niche, and they're used for very specific things. Obviously, expressing emotion is one of them, but I might just be decorating my messages. And in general, there's a sense of playfulness attached to them. And we see if those are the two things that are happening, well, obviously, we kind of have different goals with those. So if we build a Latin keyboard, then because we need to assemble many characters to make a word, we kind of have to do something that allows composition in a good way and getting from one character to the next nicely. Whereas we probably are not going to enter 200 emoji at a time. We might add one, we might add a few, but trying to find those at sporadic instances is probably more important. All right, so we ran a small study to get a more in-depth sense of what's wrong with emoji, what are some things that might be a problem right now. So for that we got 12 participants and we asked them to enter 100 emoji on the Google emoji keyboard that you can see here. So essentially you have page after page of emoji, so it's a huge list. And there are some categories at the top, and you can click on those, and then it jumps you to a specific page a bit later. And for this study, so this was a while ago, actually, so it was in 2015, and at that time we didn't have 2,000 emoji. It was a bit fewer. So we had 822 emoji in our study on an Android 5.1.1 phone. And what did we find? Well, most of it, you can see in the article, but two things really stood out, motivating where we went from this. And one is that if we asked users to find a specific emoji, they often, they went through the keyboard, and then they got to the page where that emoji is on, and then they missed it. That's kind of weird, right? That wouldn't really happen if you enter Latin characters. And then it just took them a long time navigating all those pages. Because just swiping through 40 pages, if you're really not finding one, that can take a while. So we see two things here. They kind of miss characters. That hints at, well, maybe it's more of a search thing. They're looking through those pages and they're trying to find that one character that they're looking for. Not something that we deal with in a QWERTY keyboard. And then that search that they're performing is expensive. Going through those pages just takes time. So to summarize, in our classical QWERTY keyboard, what we're really interested in is the distances between keys and how long it takes us to go from one to the next. Not what we're really interested in emoji keyboards. There it's more about how can we find them? What do we need to do to get to a specific one? And I put a hint here already, well, maybe if we are on this page here and we see those 21 emoji, we kind of have an idea what the next ones might be, and the categories also certainly put us in a certain expectation what we might find there when we get there. And the one thing that we're really working with here is this idea that if we search in a structured space, that's probably easier than just having a huge unsorted list of 2,000 emoji. So if I showed you 3 cat faces, what's the next emoji? Well, it's probably not going to be the Spanish flag, right? It's probably some other cat face, maybe some smiley face. So clearly, not every arrangement of them is equally easy for people to search. So it raises the question, well, if we have to put them in some order, if we have to put some structure to that, so how do we arrange them? And one thing actually is in the standard, and they have a sorting, a collation of emoji. And if you use that, then you can define that cow is less than Christmas tree, is less than bag of money, is less than this pair of flags. And that's not really helpful. Because what do we do with that? I mean, we can get a long list of emoji, one long line, and maybe some user is able to familiarize themselves with that concept, but it's probably not super helpful. Another thing that we do have, though, is annotations. And if we look in the Unicode Common Locale Data Repository, then we find that cow emoji actually is tagged as cow and animal. So we can see, okay, maybe other animals are also tagged as animals, and then we can do some similarity there. And for example, we then see, well, the Christmas tree and this crossed flag thing are both tagged as celebration, and all of a sudden some kind of similarity does emerge, like something that helps us structure that space. But unfortunately, those tags are limited. Let me give you one example here. Sushi and fish share no tags whatsoever, but clearly there's some relationship there. Like if I'm getting sushi, there is some fish relationship in there. So should they be close to each other? Possibly. But any of the previous data that I showed you doesn't give us any information to do that. So we set out to do something about that, and what we did is we collected data to build a semantic relationship, and we did that by just getting lots of tweets. And that essentially looks something like this. So here's a tweet of somebody wishing happy birthday to the iTunes Music Store, and you can see here, so just that things are in the same tweet gives us something, right? Like we know happy birthday appears, and all of a sudden there's the cake emoji and this party popper emoji and the balloon. So there's probably some relationship between those with the text, but also between the emoji themselves. So one tweet doesn't really get us that far. That only provides very, very limited information. So of course what we do is we collect many more of those. So we collected 20.6 million tweets. So overall, if you split that up and you kick out some stop words, then you have 228 million tokens. And essentially what we want to know is, for every one of those tokens, what's the context? What happens around it? And can we like infer some kind of relationship model from that? And for that we use a big neural network that we train with all the contexts, and out comes some 3-dimensional word vector at the end. So I'm not going to go into the technical details here, because that you can see the article, and it's also, Word2Vec is something you can just download and play with. It's not part of our contribution. But think of it like this. At the end, we get a descriptor for every token, and if it's close to another descriptor, that tells us that they're somehow semantically related. So let me show you some examples. So here is like, on the left you can see one emoji, and then on the right it gives you the 10 most closely related ones. And you can see like a sad emoji is related to heartbreak. That kind of makes sense. And the Statue of Liberty is related to the US flag. And actually I built like a small demo that I do want to show you. Let me see whether I can get to that. So you can do this interactively. So we can just pick some emojis. So for example, well, where's my mouse? Okay, we can kind of, I mean, clearly if I want clocks, then all the other clocks you can see there are very related to that. Or I could do something like, I don't know, like the happy sun, and then that's related to other nature things. But it's also related, like this is like a sunrise one, and I think the sun over the mountain. Or we can do like Ferris wheel here. And then it's related to the roller coaster. So somehow some structure emerges. Obviously we have 845 in total, so the top n are kind of interesting, but at some point it just devolves back to noise. All right. And this is for emoji, but obviously we trained with all the tokens. So we can also do something where we look at the most related emoji for text input, text like query tokens essentially. So it tells you that if you're drunk, you might want to use the beer classes clinging emoji. And if you're in love, the kissy face emoji probably is something that could be used in that kind of context. All right, so this is all kind of small samples of that space, but it's really hard to get a more global sense of what's happening, especially because it's 3-dimensional, which is just kind of unwieldy to have a look at. So one thing we did is plot this, and then you project it down to 2D, and then obviously it's distorted, right? Like, don't take this as a global best arrangement of emoji, but just as a way to look at relationships. And you can kind of see what things cluster close to each other and where there are some relationships, and I'm highlighting some here. So for example, all the positive sentiment smiley faces are in one corner, and then the negative sentiment smiley faces are slightly above them. We can see something similar happen with animals, like there's some animals at the left, and then we get water-based animals, like just close to them, and then a little bit further you find some other water activities, like going boating and fishing and that kind of thing. So clearly some structure there. All right, and I'm skipping over some of the things in the article. We also validated this. If you want some information on this, please see our article. But I want to kind of look a bit into the future. Why did we do this? What are we hoping to achieve in the long run, and what would we like to inspire others to do? So the big question really is, well, where do we go from here? We really focused on building a model of those relationships. And it is useful for predicting emoji. And again, we did this a while ago, and maybe you've already seen on your phone, you might already have that. There has been some stuff coming out after we worked on this article. For example, in summer 2016, Swift Emoji, which somehow belongs to SwiftKey, the keyboard, they brought out their emoji prediction. So it's if you do hot beach surfing, it predicts that you might want to use the surfing emoji. So multiple keyboards now have that. Some keyboards before, so the Windows Phone keyboard had a very rudimentary version of that, where they just used the annotation which I showed you earlier to provide emojis. So if you enter dragon, it would offer to replace it with a dragon emoji. But now we see more and more kind of contextual models influencing what kind of predictions are surfaced to users. But at the end of the day, something like this is still just a list, right? It still just gives you what's the tier, like 6 to choose from. And I was kind of inspired yesterday. There was the command board talk. Maybe some of you saw that. And then we get this gestural exploration of the space, and you can change the color. And I was thinking maybe that would be some direction to go with this, right? Like maybe you can explore the semantic space of emoji by doing something like that. Because at the end of the day, what really was a motivator for us is the problem that lists don't scale. You might do 500 emoji. Now we're at 2,000, and then you get some flags and some other things, and maybe then you get 10,000 or 20,000, and you probably don't want lists of those. And emoji really are only part of where this fails. And we see, especially in chat applications on phones, but also in other kind of means of communication, that the space that we want to use is much bigger than the space that our keyboards make it easy for us to use. So I want to almost end with a set of examples of what people are using right now, and all of those are kind of awkward to do at this point. So stickers, for example, huge lists. If you want to use animated GIFs, huge lists, also some search, but lots of scrolling, emoji, of course, and then there's some things that you can't really do on your phone. So I like to use like the look of disapproval at the top left. It's great for sending emails to students, but I can't do it on my phone. There's no way for me to easily enter the I characters, so I have to go to some web page and then copy it and then paste it into my text. And that's not really how we should do text entry. If I'm required to copy it from elsewhere, that's not great. So I think the challenge that we would like to pose, and where we hope to contribute a little bit, is the one of like, well, how do we move beyond grids of some buttons, where I click on the animated GIF that I want? What can we do really to build interfaces that on mobile devices, or even also on desktops, enable us to do all this wide range of things that I can communicate with? So I want to end with the information that you can download that model data. It's in the digital library. It's a bit hidden. You have to click on the source materials tab, and then there's a big zip file, and you can play with that. It's not all the tweets because that's a bit large. And if you want to read the article, I would encourage you to grab the author version, actually, because it's slightly nicer. All right, but I'd be happy to take any questions at this point.
I have a question. So can you show a prediction system?
Yep.
Yeah, and so could you use your data set to kind of improve on that directly? Or?
So this just uses like the raw feature vectors,
yeah.
Right? So it just kind of sorts all the emoji with what the closest to that is. What it doesn't really do is, look at this as like a global predicting a layout or something, right? Like this is more a different way to look at the data we collected. I think certainly where something like this is really useful is if you want to, let's say, instead of showing 2,000 emoji, you show people 200 emoji, and they're representative of the larger space. Yeah. So something you can do is you can feed all the feature vectors to a clustering model and say, I want 200 clusters. What would those be? And then use those as like starting points for people to explore. And then you get like a hierarchical drilling down into the space model.
Okay,
so,
very good. A question?
Hi, Katie Jura from Columbia University. So one of the things that they do with WordBeck that's really cool are the analogy relationships. It's like one of the things they think is special about theirs is that they can encode the semantic relationships. Have you tried doing any of those with your emojis?
I think there's a small test of that that's in the article, but I would have to look that up again. Like I haven't played with that before. But it does work to some extent, yes.
Hi, Ray Burns from Ford Motor Company. This is very social-based, which is great, right? But have you ever thought about the business applicability of using emoticons? I mean, for us, we have reams of textual information that we have to drill through to give status information on release, on requirements, state, approvals, things like that, where emoticons could really reduce the amount of time it takes us to understand where we are in a process. I imagine this would work for that. Have you ever done that kind of business-driven use for emoticons rather than just social?
We haven't looked that much into that. So I'm assuming you mean like doing some more sentiment-based use of them there, like indicating a failure state or a success state?
We will walk into a shop with a process sheet that explains exactly what someone's supposed to do, but it could be easily replaced with emoticons, right? this tool, this process, this amount of time.
Sure. I think something that would work, I mean, certainly you could, if you have words that describe a certain state, you could
Absolutely.
find tokens like in the emoticon space that correspond to them. I'm not sure whether there are necessarily emoji out there to respond to business cases.
Right now
precisely,
we respond
but
to a myriad of three-letter acronyms, right, that people have to memorize as opposed to something that's very memorable and graphical. So we
think
have to
at-
create our own emoticons, yeah.
I think at the end something that is really powerful about them is, and that is not immediately obvious necessarily, that they are text, right?
Right.
Like if you just have a text-based user interface, you can just copy them in there. Like you can use them in PCS, you can put them in your paper title. They don't make it into the WISP program, but I mean, you can do it.
Thank you.
Thank you. Thank you very much.